Καλημέρα σε όλους και καλώς ήρθατε σε ακόμα ένα σεμινάριο του Τμήματος Φυσικής για φέτος. Σήμερα έχουμε ένα αρκετά ιδιαίτερο θέμα, εξωτικό θα λέγει κανείς, την πυρηνική εγκληματολογία, με την Dr. Széles. Ένα θέμα το οποίο μπορεί να ακούγεται έτσι εξωτικό, αλλά έχει πάρα πολύ φυσική από πίσω. Και μάλιστα, αν κάποιος από εσάς το βρει ενδιαφέρον, μέσω της κυρίας Ιωαννίδου, κάποιους παλιότεροι φοιτητές μας έχουν πάει στο Ινστιτούτο της κυρίας Széles και έχουν κάνει εράσμους εκεί, έχουν μάθει δηλαδή για αυτά τα πράγματα λίγο περισσότερα. So I switch to English now. Dr. Széles, welcome to Thessaloniki. Thanks a lot for being with us today. Dr. Széles holds a PhD degree on analytical chemistry. Her background is radiochemistry, analysis of nuclear materials by mass spectroscopy. Presently, Dr. Széles is working at the HUN-REN Center for Energy Research in Hungary as a special scientific advisor on nuclear security of materials outside of regulatory control, including multi-agency response to criminal and other international unauthorized acts, radiological crime scene management, nuclear forensics, and criminal prosecution of radionuclear crimes. Dr. Széles is supporting to strengthen the Hungarian national security strategies, multi-agency cooperation, and regional and international capacity building on security. Her expertise is also covering training and exercise development. So, without further ado.
Good afternoon, everyone. Can you hear me? Okay, thank you. Thank you for the kind introduction. And first of all, this is my great pleasure and honor to be here today. And the dream became real because my favorite country is Greece, I have to tell you. I spent some time here in this country when I was very young, many years ago, at the university in Athens. And it was one of the happiest time in my life, and I never thought I will come back as a lecturer. So it's a special honor for me. Today, I will give you some information about nuclear forensics, which is for me a very special, very interesting area, and I hope you will enjoy this presentation. The presentation itself is not deeply scientific. I hope it's more interesting and exciting, but everything is behind nuclear forensics or forensic science is a pure science, scientific research. Of course, I will also give you some examples. First of all, it's a very basic information. I am not sure how many of you, maybe all of you, this is the best case, familiar with radioactivity and what is radioactive material or nuclear material. So I don't want to give you a presentation, a basic presentation on radiation, which like in a primary school. But something important to know about especially nuclear materials, which are special type of radioactive materials. We know, of course, the radioactive materials contains atoms which are unstable, and because of the instability, after some time, they spontaneously decay. They will release a special energy, which is the radiation. Ionizing or non-ionizing radiation, doesn't matter. And nuclear materials radioactive materials is more or less scientific category. Nuclear materials is the category from the International Atomic Energy Agency. Special radioactive materials which has special behaviors like to have a self-sustaining chain reaction, which means that these materials are useful to produce energy, electricity. Therefore, these materials, namely the uranium and plutonium, and also partly the thorium, these are the main nuclear materials, or uranium and plutonium actually. They are used for different purposes, to get energy, and they are used for peaceful purposes and not peaceful purposes. Peaceful is using in nuclear reactors to producing electricity, and not peaceful use is the nuclear weapons. This is one area. But it's something in this presentation I won't speak about nuclear weapons, because nuclear weapons belong to the military area, and using these like weapons using for war cases or using for military purposes. In this presentation, we will speak more about terrorism and special tools using or containing radioactive materials. Nuclear terrorism. That's a very special area, a special area of terrorism, and which is, terrorism increase, unfortunately, showing, unfortunately, an increasing trend nowadays, and there are more and more terror attacks in all over the world, also including in Europe. And actually, the main goal of the terrorists or terrorist attacks is to causing panic and economical damage in the population, in the public, and using the fear as a strategic tool and threatening people in order to have some to reach some political or ideological goals. So this is something, but the terrorist has different tools, of course, and one of the subcategory of terrorism is the nuclear terrorism, which means that the terrorists can use nuclear or other radioactive materials, not only nuclear materials, for their purposes, fabricating special devices, using at public places, and threatening people. Or another possibility is attacking nuclear reactors and to cause any sabotage. This is something, it's a global definition about this nuclear terrorism, and the threat is the terrorists. The threat is the people who have motivation and intention and capability to do something. And if we are speaking about the special devices, which is the definitions coming from the International Atomic Energy Agency, these special devices are not weapons. These are fabricated devices containing radioactive materials. Radiological dispersal device, the popular name is dirty bomb. That means that traditional, normal, conventional explosive packaged together with radioactive material. After this device is exploded, fortunately it's never happened, hasn't happened yet, this situation, but if it's exploded, it can spread the radioactive material. What does it mean? A large area will be contaminated, like public places, a square full with people, or can you imagine in a concert? There are many people exploded this bomb. The goal of terrorists is not killing many people. It's not a mass destructive weapon. It's again causing panic. Explosion, even it's small, it's already fearful, but if the terrorists post on the social media, we exploded a bomb with radioactive material, everybody will be in a huge panic. So therefore it's a very good tool for terrorists to use it for. Hopefully they will never use it, but we know about cases when they tried. So this is something, but the dispersal devices can be not only a bomb, it can be also something like to put the radioactive material into an air conditioning system. Can you imagine if there is a huge shopping mall, a small cafeteria in the shopping mall, and putting some radioactive salt to the air conditioning? After 2 days, posting on the social media, we put some radioactive material to this cafeteria, the air conditioning system, and how many people during 2 days in a shopping mall were contaminated in this cafeteria. The full shopping mall can be contaminated, and it's a huge problem to find the people who were contaminated, treat the people, how to messaging in the media without causing even higher panic, and how to decontaminate the building. This has very high consequences. Another is the radiation exposure device. This is not so effective, but it's not impossible to use. If we place a very highly radioactive source to a public place or a tactical place, to a train station, to a train, to an event, and people who are there or walking there or just sitting there, they will exposed by radiation. This is another possibility to use, but again, it's easier to steal highly radioactive materials somehow like nuclear materials, but it's not so effective as the dispersal device. Improvised nuclear device is a so-called homemade nuclear weapon and a small atomic bomb. It's very complicated to produce, but it's not impossible. And it has a similar effect like a nuclear bomb, so it has the nuclear yield reaction, but it's a very small bomb. And again, produce a nuclear weapon is an atomic bomb is extremely complicated. A very, very complicated technology is needed for it. It's not easy to set up, establish, or buy. Therefore, it's the chance is very low for terrorists to build up a nuclear weapon, but improvised nuclear device is easier, but still very complicated. What kind of materials can be used for these devices? Everything which is radioactive, everything, including if we package together with the explosive nuclear material some uranium and we explode it, it is not a nuclear explosion. It's a normal explosion and spreading some uranium everywhere. Uranium normally is not highly radioactive. So it's toxic as a heavy metal, but not highly radioactive. But can you imagine if somebody posting on the media, I exploded a bomb with uranium, everybody will think on nuclear weapon. So therefore this device is effective. So all the different type of radioactive materials can be useful for the RDD, the dirty bomb. But for RED, the exposure device, just highly radioactive sources, as I mentioned. And you know, sometimes these sources, as you can see on the picture on here, on the right side, sometimes these sources are extremely small, some millimeters, but so radioactive, if you go close to the source, within minutes you will get the lethal dose. And after 2 weeks, the person who was exposed will die. So that's a can be very effective tool also, but for less people. Uranium. So something I wanted to show you like a scientific details on uranium because it's not too many people know it. The uranium has different types, following also the definitions and the so-called enrichment, because the uranium has only one isotope. The isotopic mass is 235. Uranium-235, which is the fissionable isotope, and this is the only useful isotope to produce the energy and this chain reaction in the reactors. So therefore, if we want to have a more effective nuclear fuel in a reactor, we have to enrich the uranium in this isotope. We have to increase the amount of this isotope. So that's the natural in the nature. The uranium contains only 0.72% from this isotope. Is not too much. But if we enrich in it, then we will get so-called low-enriched uranium. They are typically used until 20%, typically used in nuclear power plants, nuclear reactors. Highly enriched uranium is not really allowed to use anymore in all over the world because it can be used for nuclear weapon production. But still there are some research reactors who are using highly enriched uranium, which is above 20%. And we have uranium enriched in 90% 235, which is almost the pure U-35 isotope. That's the weapons grade uranium. It can be used directly for nuclear weapon production, this nuclear weapon, atomic bomb. And we need about 8 kilos from this isotope purely, and then 8 kilo is more or less the amount for a nuclear weapon. But again, it's very hard to find this kind of nuclear material. Plutonium also has different type, and I just wanted to show that the weapon-grade plutonium is the pure, almost pure, not pure, but about 92% of plutonium-239 isotope. If you have this isotope, it can be useful for a plutonium bomb. These other categories based on related to nuclear terrorism, and if we have these materials found somewhere and we have to analyze the material, there are different categories that we have to use or we should add and report for the law enforcement or police or the regulatory bodies. Direct use materials, directly used for nuclear weapon production, like highly enriched uranium. Indirect use is the low enriched because it needs or depleted, which is less than the natural content into uranium-235. It needs lots of technological steps to enrich further until weapon-grade uranium, so it's not useful for direct weapon production. And radioactive sources, of course, medical, industrial, in many places radioactive material are used because they are very useful for diagnostic or purposes of treatments, medical treatments, or industrial. This is a short table. I don't want to tell all the details. Don't read it. It's too much complicated. Just again to compare with nuclear weapon with the other devices. As I mentioned, the weaponization technologies for nuclear weapon is extremely sophisticated and confidential. It's very hard to find this technology. It's not possible to find this technology in open internet or others. But for the others, it's trivia, because how to put together a radioactive material with an explosive, it's not a big deal. The explosion itself is a deal, actually, because should be exploded up and going down the radioactive material, otherwise it will be it's too much diluted. But anyway, these are much more easier to create devices. But of course, the effect is also lower. There are no no casualties, no dead people, or not too many, just because of the explosion. But it has, again, economical effect. Consequences. If we would have, hopefully we never have this situation, but if yes, there are large area, as I mentioned, will be contaminated, and we have to handle somehow the situation. Decontaminate the people. These pictures are from exercises and not from real situations. But you know, you have to decontaminate the people with some shower and changing, discarding all the clothes and giving them a new clothes or something like that, like a paper suit or plastic suit. Sorry. And some other consequences which are extremely expensive, and again destroying the, for example, in the trust of the country. So, for example, the tourism will be decreased, and it can cause economical damage for a state. Okay, we were speaking a lot about terrorism, and now something others which are also related to here, and why we need nuclear forensics at the end, is the so-called criminal cases or other intentional cases. Because if we have radioactive materials in the wrong hands, so it's without control or leaving the so-called regulatory control, then we can have lots of different activities. Criminals, not only terrorists, but criminals can also use these materials. Illicit trafficking is the illicit transport. So the materials can be bought from the illegal market. This is really true. There is most probably everybody heard about the darknet. Darknet, and the darknet you can find easily radioactive materials to be bought. So it's not a deal to buy radioactive material for huge money. And also it's possible to steal them, very hard, it's not easy, but possible to steal from the transport of these materials or a facility, producing facility or user, and then transport to another place. This is the illicit trafficking, sometimes through countries and borders, to prepare these devices or to sell them in an illegal market again, or for illegal trade. They have really high price. I will show you a real case now, soon, after this slide, which is, I think it's very interesting. But not only the real cases with, and it is real case, but that type of case. So the real case is always interesting, but not only the cases when there was real radioactive material in the case, but sometimes there are only scams or hoaxes, which is a cheating without any real radioactive material, but people try to sell it or try to do something with that. In the 90s and 2000 years, in the 2000s, for early years, there were lots of cases about this so-called red mercury. Maybe you heard about it. Red mercury was confiscated at border stations, were smuggled by people. This is a fake something. Red mercury is a radioactive material, it doesn't exist. That's a fake thing. That's just for money, it's really not, how to say, people are doing sometimes many things for money. So that's another case which happened in 2019 in Vienna. You can find this case in the web page of the Europol. Even on the link, you can see a video about this case. That was a very interesting case when the police there was an information to the police, the Austrian and Moldovan police coming to the information, group of criminals, some criminals, try to sell uranium in the illegal market. And as you can see on the slide, it was a container with 100, 200 grams of uranium, they told to the customer, and they tried to sell it for 3 million euros. It's unbelievable price for 100 or 150 grams uranium. It's a very high price, so there was the business which started to build up somehow, and the police followed the case, And in Austria, in Vienna, they stopped the car with the criminals, and they arrested 3 people. They removed them from the car, and also they checked the car with special equipment and special tools. And they found this, and so the picture is not so good, but they found a very a suspicious green container in the trunk of the car. First they checked with X-ray machine whether is it maybe some explosive inside or not. It's not really easy to see, but in the picture they didn't see explosives, just something inside which is like stones or something like that. And they didn't detect any radioactivity. But they transported to the laboratory and opened this container, and really there was nothing radioactive inside, nothing uranium, that was just sand and stones. So that was a real hoax, I mean, not a real material, but again, they tried to sell this nothing for 3 million euros. Okay, so these are the case, and now we will arrive very soon to nuclear forensics. If we have a situation when the material was detected, or even the material was found somewhere and people try to use for some purpose, we have to collect evidences. So we have to start, in most of the cases there is a criminal case behind, so it's a smuggling at a border station. We have to initiate the criminal investigation and collect evidences, which is the so-called radiological crime scene management. We have a crime scene, like a conventional crime scene, but we can find there also radioactive materials, so we have to handle the crime scene in a special way, following special procedures, considering the radiological hazard. But nuclear or other radioactive material is also an evidence in a case, not only others like fingerprints. And we have to analyze these materials, what kind of the materials we have, where they came from, and so on. This is the task of nuclear forensics, and prosecute the case at the courtroom. And to have the real proper procedure for the criminals, to send them to the jail or just to punish for some money punishment or anything else. So this is somehow the process: crime scene management and evidence collection and the crime scene. And then in the field, this is already somehow science, but it looks maybe not, but gamma spectrometry should be used at the crime scene to determine the type of uranium, whether is it low enriched, highly enriched, weapon grade natural uranium. And this measurement can be done only by experts, nuclear physicists in most of the cases, who has experience with nuclear materials and lots of experience with measurements of nuclear materials using gamma spectrometry, and then transporting to the laboratory and analyze in more details in the laboratory to answer the questions of the investigators or prosecutor. So, by definition, what is nuclear forensics? It's a very long sentence coming from the document of the Nuclear Security Series, a guidance from the International Atomic Energy Agency. Nuclear forensics is the examination of nuclear or other radioactive material, or, which is interesting, evidence contaminated with radionuclides. Because if we have a crime scene, maybe like this place, and contaminated spreaded material, maybe we will have here fingerprints, we will have a mobile phone with data and other objects, but contaminated, radioactive. These objects should be analyzed also, but normal police lab cannot do it in most of the cases. So we have to analyze this. Why? Because it's forensic science. Forensic science has the goal to find the linkage between the material itself and people, places, and events. What does it mean? Very simple example, what I already mentioned: border. There is a border station, a border checkpoint. A car tried to cross the border, and at the borders in many borders, so most of them, there are radiation portal monitors, radiation detectors. So cars the car tried to cross the border, and the detectors start to alarm. And the border police can realize, okay, something radioactive is in this car, and they check the car, and they find some radioactive objects in the car, without any license, without documentation, nothing. So it's not a legal transport, it's something illegal, it's a smuggling. And asking the driver, the guy who was the driver of the car, okay, you have here radioactive objects in your car. What about this radioactive material, and what did you want to do with this then? Okay, it's a very simplified example, but it actually happening every day almost, or many cases. And what will the guy know? What will the guy tell? Is it mine? No. No, this I have no clue. I don't know. I don't know. I gave my car to my friend last week, and he used my car. I have no idea how it was in my car. I completely, I don't know. So it's a very simplified example, but forensics should find the evidence whether this guy, the driver, is the smuggler, and he is responsible for the materials or not. And what was his purpose with the material, or where the material came from. So it was stolen from where? Who was the original licensee? So that's or original owner. So that's the task somehow forensics. It's again a very simplified example. And forensic is forensic. So again, another example following this picture. And this was another real case, happened in 1999, many years ago, in the Bulgarian border. They found confiscated this small glass ampule with highly enriched uranium. So it was a uranium powder inside. But for this ampule was inside in a lead container, so-called shielding and other objects. So the target of nuclear forensics is the powder, the black or yellow or dark gray powder. We have to analyze that material. And anything else, like the container, the type of the container, the material, and so on, belongs to traditional forensics. Not nuclear, traditional. They are checking the material of the container, some other traces in the wax inside, or something like that. This is to understand, and actually at the end of the case, we have to connect the evidences from traditional and nuclear forensics. We have to connect, and we can give the full picture to the police officers or prosecutors about the case, who is related. Then again, here is it's another very simplified example for a case. If traditional forensic and crimes investigation and others, that's if we have there is a case, a person was murdered, so there is a murder. And the investigators can find at the crime scene, maybe, or that is a simplified example, the tool of perpetration, for example, a knife with some blood and fingerprints and so on. They have to analyze these evidences, the blood and fingerprints, in order to know who was the murderer, who is responsible for this case. And this is the target of traditional forensics. I am speaking about conventional cases, not nuclear cases, but exactly the same situation for nuclear forensics. But in this case, the target is the nuclear material for us to analyze. And I already mentioned this, I don't want to go through again. The task of nuclear forensics is supporting the criminal investigation, prosecution, with answering the questions of the investigative authority or prosecutor. What is the material, which law was broken, who is responsible, and many other questions that police are asking. And based on different sophisticated analytical measurements. And the other function of forensics is to pay attention for the authorities if something was wrong with the protection system of facilities. If it's possible to steal nuclear material from a facility, the protection system is not okay. The authorities should go back and pay attention that you have to increase your protection system because it's not okay. Or the material could travel through countries and borders. Border protection is not okay, so authorities again should strengthen the borders. This is something, again, a task, another task, a subtask, or other main task of forensics, nuclear forensics. How it is doing, the nuclear forensics can help to identify the origin and history of the material and the original producer of the material. How? These materials has special characteristic parameters what we can analyze with different analytical techniques, And from all the analytical data, we can find the origin if we have a database to compare our data with a database. What does it mean? It's again the same. If you have a conventional case, there is a fingerprint at the crime scene, an expert can analyze, it's not highly science, but can analyze, and then they have a database for fingerprints, and if it's matched with somebody, then they found the person. This is similar, but of course much more complicated, and using lots of different techniques, because if we are speaking about nuclear materials, they are produced through the nuclear fuel cycle, which is here the mining of uranium ore, conversion to another form for enrichment, enriching in uranium-235, using in a fuel fabrication, then producing the pellets, and using in a reactor and sending final the repository, or clean it from the decay products and prepare again a fresh fuel and sending back to the nuclear fuel cycle. This is another option. So, but during this full process, there are lots of chemical, physical and technological operations or procedures which are used, different, lots of chemicals and others, which can leave the traces in the material inside. And based on the technology what the producer is using, leaving different traces, impurities in the material. And if we measure these different special characteristic parameters, we can identify or exclude the producer or the origin of the material. You can see some examples for the characteristic parameters. Physical characteristics is very simple. I will show you an example. Chemical composition, isotopic ratio, enrichment. Even we can determine the production date, when the material was produced, in which time. That needs higher scientific methods, but it's possible. And it's one of the most important parameters when the material was produced. I showed already this picture. You can see again some different parameters for this case from traditional and nuclear forensic perspective. Radioactive sources, because we are not speaking about only nuclear materials, we should speak about radioactive sources, as I mentioned. If we have a radioactive source without any information, so we found it or it was confiscated, how can we find the original owner and where was it stolen or who was the producer? There are other characteristic parameters for sources. If we are very lucky, in most of the cases we are not lucky, there are serial numbers on the source or even the sign with the producer. If not, there are some other parameters like impurities, gamma emitters, radioactive impurities, contaminating elements in the source itself. Or very important, interesting parameter is the material of the capsule. This is the source, radioactive source inside in this metallic so-called capsule. As in the X-ray picture, you can see this is the capsule. It's a californium source. It's a capsule and the source is inside here. It's about 1 millimeter. That's a very, very, very small source and highly radioactive. And if we measure using the X-ray tomography, then we can see how it looks like inside. This is one characteristic parameter. And even that how it looks like is one important. And yes, and the material, this is not the same source, but the material of the capsule is really interesting. It's a special type of alloy or stainless steel, but special type. And we measured lots of sources, and we found that depends on not all of them, but many producers are using different specific stainless steel or alloy for the capsule material. So even just measure the type of the metal, we can find or identify some producers. That's a very interesting. It was a very interesting finding during the research. Others I mentioned already. Traditional forensic evidence is contaminated with radionuclides. This is the full process. I already mentioned. I don't want to go again. This is a full process for forensics, starting in the crime scene and then evidence collection, and then build up different plans how to do the analysis. And what about data interpretation and forensic findings? Forensic examination plan is the first plan. We have the case, we have lots of different evidences, nuclear material, fingerprint, and DNA, and others. And this plan is like an umbrella, is containing the full planning of the examination, Altica measurements and different measurements on the different evidences, including traditional evidence and nuclear materials or radioactive materials, or contaminated evidences, how to do it. Nuclear forensic Altica plan is just in nuclear forensic laboratory. We have to plan the analysis very carefully, how to do it step by step. Depends the questions of the investigative authority, the police, what kind of material we have and how much, and techniques available. Why? Because if the police asking me, okay, we have this material, is it radioactive? And if yes, but is it nuclear or not? Which kind of nuclear? What I have to do? I can use only so-called gamma spectrometry to measure this sample, and I don't need any other techniques because I could answer the questions. But if they have more sophisticated questions and they want to know the origin of the material and the owner, then I need many other techniques. Type, it depends on uranium or others, and quantity. If I have a ton of or tons of nuclear or uranium or uranium ore concentrate samples, that's a completely story in the laboratory how to measure tons or have sampling from the sample, representative sampling, or I have just one single piece of nuclear fuel pellet. This is not the same case. So that's, I have to plan the analysis on different way. And techniques available. If the police asking me a very sophisticated question, but I need a very fancy analytical technique for it, but I don't have in my laboratory, I cannot use it. So I have to find, the proper techniques. How it looks like. After the sample arrived to the laboratory, there is a process, should be a process, a very, very complicated process, and it's very important to mention that this is not like a normal analytical measurement. Sample arrived in the lab, we measured with some technique. This is not enough. This is an evidence. We have to follow the rules for evidence. We have to follow it's like quality assurance. When we follow the road of the evidence or the material is going from one laboratory to another laboratory, who is measuring on which point and when and so on. And it's not allowed to broke this chain of following the life of the material, because if we break this chain and there is a point when the material was alone in the laboratory and nobody was there, that's okay. It's a question how the police will know it, but if we break this chain and the material was alone, that was a possibility to manipulate with the material, manipulate with the evidence, which means that the court at the end doesn't accept the material as evidence anymore. This is not an evidence anymore, which means that we don't have evidence. The guy, the terrorist, can walk away because maybe the main evidence was just a radioactive material. It's just again a simplified example. Anyway, so very important, the quality assurance and the so-called chain of custody, which is the following the evidence, and the different techniques and planning the techniques and sequencing of the techniques. First is always some kind of non-destructive, which is we have the sample itself and we can put to a device which is not destroying the sample, like gamma spectrometry or some quasi non-destructive techniques using electron microscope or something like that. And we can analyze it. If it's necessary, later, we can have a subsampling, so cut a piece of the material or remove a small part from a powder, and using nice, really long, time-consuming, boring, very strange chemistry. Sorry, I'm a chemist, so I can tell it in the laboratory. That's a very, very complicated procedure, use the radiochemistry, and sometimes it takes 3-4 weeks to prepare the sample for mass spectrometry analysis or other type of analysis. So this is the sequencing of the techniques, and this is another nice table. How many different techniques are suggested to be used for nuclear forensics? and time frames, because the police sometimes requesting the reporting after the first 24 hours if we have an urgent case. We have to prevent a terror attack somewhere. We have to give the first measurement data to the police as soon as possible. Sometimes they're requesting data within 24 hours, then after a week, but the final report always, this is official case in almost all of the countries, after 2 months, we have to send a full report to the police. And what we can do within 24 hours, not too many things. That's we can have some radiometric measurement, doses, activity, then some optical microscopic measurement, gamma spectrometry can be very fast, so we can use it. 1 week, we need more special techniques, complicated techniques, different type of mass spectrometers, very special types or electron microscopic techniques. And in the 2 months, that is not here, but radiochemistry and alpha spectrometry also needs long radiochemistry. So some techniques needs long time for the measurement, but again, you can see lots of different analytical techniques suggested to be used for forensics, not absolutely necessary, just they can be used for nuclear forensics. And again, behind them, pure science, develop the methods, analytical methods, and understand the data. And in most of the cases, a nuclear forensic expert is not expert in all the techniques, it's impossible. But working with operators and scientists who are operating these instruments and requesting the special measurements, and at the end they understand together or discussing together the findings, the analytical data. And this is the data interpretation. We need a subject matter expert. We need an expert who is expert on reactor physics, expert in how to produce radioactive sources, expert on different areas, and will understand all this analytical data together, what is the meaning of the analytical data, and how can support the criminal investigation. And at the end, we have to write a report and send to the prosecutor or criminal investigator about all the findings. This is also nice because we are writing on a high scientific way the reports. Really important to be very precise scientifically. But you know, police officers won't understand a single word from the scientific explanation. So there is another effort to write some pages in the report which is completely understandable for anybody. Even you stop somebody in the street and he will or she will understand what you are speaking about. That's something which is extremely important, and also to represent the case at the courtroom in front of the judge and prosecutors and lawyers on the way which is understandable. It's not high science, but very interesting and quite challenging. Sorry about the stories, but it happened once. I was in an exercise for mock trial. Mock trial means that's a courtroom case, to be an expert at the courtroom, but it was just an exercise, not a real case. And the defense lawyer asked me the following question. The case was about a cobalt-60 highly radioactive source. It was stolen, and the criminal tried to use for some malicious act. And the lawyer asked me the following question. As I know, cobalt-60 is used in teletherapeutic instruments or in the hospital for cancer treatment. And I told, yes, this is correct. This type of material is used for medical purposes. But in this case, my question is that why we cannot have cobalt-60 at home? It can increase our health. And why this is a criminal case? You know, as an expert, I know it's a very stupid question, but it was very challenging to answer on a way which is understandable, but still precise scientifically. Why it is not okay if you have at home highly radioactive source. Anyway, that was just one case. Pure science, I just wanted to show you shortly a slide about that. A very famous scientist wrote an article to the Nature. Maybe you already heard about the Nature, which is the most famous top-level scientific journal. There was an article about nuclear forensics, so it also shows that it's a high scientific area. And there are different expertise. You can see how many different expertise is needed for nuclear forensics. not only analytical chemistry or physics, but also many other things, geochemistry and cosmochemistry. Okay, it was the theory about nuclear forensics, and I would like to show at the end just shortly some examples from Hungary, some other cases which are not so serious but maybe interesting. Nuclear forensics started in Hungary in the 90s. We had lots of confiscations at the border, eastern border, because after the collapse of the former Soviet Union, this material started to traveling around Eastern Europe, including Hungary, and the police or border police confiscated different type of nuclear fuel pellets, and they had to do something with these materials. And as our institute had already decades experience on nuclear physics, they found our institute, and already in 1996, they delegated the task of nuclear forensics to our institute. So our institute is doing officially, legally, nuclear forensic examination for the law enforcement, for the police, from that time, 30 years. So you can see some developments of our techniques in 2000, from 2002 to 2022. It's a little bit different. We have this kind of analytical techniques from gamma spec and other mass spectrometry and many other X-ray techniques, X-ray fluorescence or diffraction or X-ray tomography, and we also have a research reactor, so we can have also even neutron tomography when we can see in a lead container behind the shielding what is inside, like a fuel pellet. Okay, cases. That's real confiscations from the 90s. Case 1 and 2, they were these pellets, and sorry for pictures are very awful, the quality. Nowadays we are taking high professional pictures following the rules of criminal photography, but at that time it was the photo type. And actually these pellets were confiscated on different time, different confiscations, not the same. And after the measurements by gamma spectrometry, my colleagues found that these were natural uranium, which is very surprised for a nuclear reactor, but some special type of reactor is using natural uranium, not enriched, which is the so-called CANDU type of reactors. And as Romania has CANDU type of reactor, we found the origin was Romania. So the sample was transported back to Romania. And then other two pellets, already from our eyes, visually identical. So we can see that, oh, they are really similar. They were also from different confiscations originating. And based on, again, measurements and how they look like, if you find a pellet with nuclear fuel pellet with the hole inside, is definitely coming from the eastern part of the world, from Russia or from Kazakhstan. So that was already an indicator, but they measured, they found that it was an RBMK 1500 type of fuel, 2% enriched uranium, and the production year was 1992, both of them. So they could connect these cases, and the origin was from Elektrostal, the city from Russia. So it was some interesting cases, and production date, just very shortly about this production date, because I think it's really interesting. If the uranium is purified before they producing these small pellets, the tablets, they have to purify and clean the uranium from everything else, because the uranium fuel can be used effectively in a reactor if it doesn't contain any contaminating elements. If there are contamination in the uranium, it's not effective fuel, so it's causing bad, nothing bad for the reactor, but it's not so good enough. So they have to purify it, which means chemically separate the uranium from everything else, including the decay products, the daughter elements. So after they preparing this uranium, but the uranium is radioactive, so the decay will be continued, then the daughter elements will born again. Then after some time, knowing the half-life, we can calculate back when this last purification step happened with uranium, and this is the production date of uranium. So it's possible to measure by mass spectrometry based on this isotopic clock, which is known from geochemistry, and by gamma spec other isotopes useful for this determination. Okay. I am close to the end, just some slides. So this is another case, happened in a big facility. I don't want to mention where, but it was a very interesting crime scene with lots of different, it was our first radiological crime scene together with the police officers, investigators, and the bomb experts, because there was a report about a person who tried to produce maybe a dirty bomb with nuclear material and explosives, producing explosives. And there was a storage, you can see on the picture, the storage full with chemicals, and the laboratories, and many other things. And altogether, which was a surprise for us too, altogether we collected 1.3 kilo nuclear materials. It was not a serious case. These are just laboratory chemicals. This is nothing, the guy didn't want to do any dirty bomb. Just it was somehow reporting about him. And we measured with these samples with many different techniques actually to see what are the materials and to identify them. And finally, we found that they were altogether were this about 700 gram uranium and 600 gram thorium. The chemical forms were identified using Fourier transformation infrared spectroscopy. They were the different chemicals, what you can see there, and most of them were natural uranium, conventional laboratory chemicals, and some of them were prepared from depleted uranium with this special isotopic content. This is originating only from uranium, which was already in a reactor, and it was irradiated in a reactor by neutrons. So these chemicals were originated from a reprocessing plant, which is used spent fuel for reproduce it. It is another case which is similar. It's also the same laboratory chemical or similar chemical. It was another case in Hungary, is very popular. I mean, I don't know why. That was another report about a guy in the countryside who is trying to producing RDD, the dirty bomb. And there was a home search by the police in his apartment. They collected this nuclear material and sent to our laboratory. And I wanted to show you just some pictures about the crime scene, which is quite, it's strange but quite funny, because they found lots of chemicals which are good for explosive production, and the guy stored in the fridge together with the food. So all these chemicals and organic liquids were in his fridge. That's really nice. And you can see some eggs was inside and jam and I don't know what else. So the police found all these chemicals and sent not the explosives, I mean, not the organic materials, because liquids, it's not our business, but they transported this material to our laboratory, and we measured with different techniques, and again, the infrared spectroscopy could show us this is really, it was uranyl acetate, laboratory chemical, and don't read it, it's a very busy slide. I just wanted to show that these were the questions of the investigative authority, sometimes not the proper questions, like, okay, what is the material? Is it radioactive or nuclear? Yes, it was radioactive and nuclear. And type and amount, it was altogether 84 grams and depleted uranium, so it was also coming from a reprocession plant. But this question is not for a nuclear forensic expert. I'm always arguing with the police, but still we get this question, what hazards does it pose? What kind of effects has this material? Biological effect. And this is not a question of a nuclear forensic expert. In this case, we answer on the way the chemical toxicology, I mean like how toxic is the material. And mainly we are answering from the perspective of radiation protection. If the person has this material and bringing with him or her or giving another person who doesn't know it's radioactive, how much those will be absorbed by the person. So we are answering these questions from this perspective, but we always highlight in the report for the police, this is not our responsibility. We answer the questions, but we are not experts in toxicology. So this is something, and yeah, do you have another fancy question? Like, are the materials dangerous radioactive materials according to the criminal law? How can you answer it? It's not an easy yes and no. So can be if you eat all of the full glass, you eat it, you will die definitely. But from radiation protection perspective, it's it's not really so anyway. And what kind of licenses you need? This is nuclear material, so even a milligram is not allowed to have at home without permission or license. Okay, this is my last slide, I think. I just wanted to show very I already mentioned some research on forensics. This is a new direction. We had lots of research on nuclear materials, and nowadays we turn to the radioactive sources, and we use different techniques for the signature study, so to find characteristic parameters, and we found some. This is the main component analysis and some statistical evaluation of different sources. And as I mentioned, the material of the capsule is very informative. Using a handheld XRF technique is very easy to measure. And some sophisticated measurements by gamma spectrometry and neutron measurements. We found other characteristic parameters like the neutron yield. These were neutron sources. Neutron yields and other different isotopic composition or ratios like curium ratios. And one more is we found this is one source originating from Russia, another originating from the USA, and one of them contains lots of different European isotopes. However, it was a Californium source. And the other source, as you can see, the peaks are missing, so the other source doesn't contain any European isotope, which is a good indicator for the origin of the source. That's all from my side. The summary is just what I explained already. Nuclear forensics supporting investigation and with the answering the questions of authorities. And this is really an important area, interesting area, and as I mentioned, that's pure science behind, more or less. Thank you for your attention.
Thanks a lot, Eva. So are there any questions from the students?
Hello, Eva. You said that for the examination of the materials, for some tests, they're done immediately, but others, like the FTIR, was 1 week. The gas chromatography and mass spectroscopy, like 2 months. Why do you have to wait for such a long time? While these tests, we know they can be done immediately. Why is there such a long time delay?
We are not waiting for them. That's sometimes the FTR needs some sample preparation, but you are right. It's possible to do within 24 hours. But the 24 hours is dedicated mainly for physical characterization, which means like taking photos, using microscopic techniques and others. So we are not waiting for that. Just some measurements has priority before the infrared spectroscopy. And for mass spectrometry, as I mentioned, that we have to use chemistry, very special chemistry for the preparation of the samples, radiochemistry separation techniques, and it needs sometimes 3 weeks, the chemistry. So that's therefore in the 2 months reporting, because it's really funny, 3-4 weeks chemistry, 1 day measurement, 2 days calculation of the results, so it's a long time. The chemistry is very time consuming, very special.
Any other questions?
Hello. How is the job market in nuclear physics compared to other fields of applied physics? And what kind of masters or preparation is necessary to apply to an institution like yours?
Mine or the nuclear forensics? Or, sorry.
I mean, if you want to pursue a career in a forensic science or nuclear forensic science, do you need the specified masters for that course, or is it just necessary to have a nuclear physics general masters?
Okay, thank you, I understand. No, you don't need it, and actually it's not possible because there is no any university in the world which is giving master or, I mean, a specific program for nuclear forensics itself. This is a subtopic of some kind of educational program. Some universities, as also in Hungary, we integrated to the education, but just like a seminar, so 1.5 year or 1 year, something like that. And enough. enough to be a nuclear physicist or chemist or the normal conventional degree. And then if you join to this work, to a special laboratory, you will learn it because you have to learn. The expertise on nuclear forensics is coming from the practice and also from working together with experts who are experts in this field. And one more thing, however, there are master programs. I mean, in Hungary also we had in the institute already 4 or 5 MSc degree on nuclear forensics and also a PhD actually, which is the guys were physicists or chemists, and we gave them a special topic on this nuclear forensics area, scientific research, and they wrote the MSc thesis about nuclear forensics, but at the end the degree is not, this is not nuclear forensic expert or what, chemist or physicist specified for this area or something like that. Thanks.
Thanks for the nice presentation. You already mentioned there is a big distance between the scientist and the authorities, okay, the judge or the prosecutor, etc. So there is a high probability that you are lost in translation, okay? So he doesn't get the proper information. So, and his decision is based on that. So do they get any special training, or you get any special training in order to be able to transmit properly the information?
Thank you. That's a very important question because really that's one of the biggest challenge, the communication, because they don't understand the scientific language, and even we are not professionals in the law enforcement area. However, a nuclear forensic expert should understand the laws and how it is working. We started to be programs just recently all over the world on this training, cross type of training, which is inviting both scientists and law enforcement and train them together as an awareness training and exercises. And trainings and exercises for judges and prosecutors. There are more and more programs organized by UN organizations, the United Nations Drugs and Crimes, and the UNICRI, and also the IAEA. They have programs for this purpose, to understand each other, because the prosecutors should be prepared also to present the case or on the court. And the training is also included the training of, and actually the Netherlands has excellent trainings for this purpose, training of the experts, the forensic experts, how to be an expert witness at the courtroom and how to present the, so there are trainings available, just started 2 years ago.
Any other question?
So in every case, the scientists begin with an unknown source, right? Like we don't know anything. So are there any special protection protocols for the scientists to protect themselves from the unknown source?
That's also a nice question, thank you. Yes, this is extremely important, and this is something that we also highlight that in Hungary, again, in our example, that the nuclear forensic experts or radiological experts working together with the police at the crime scene. So we are in one team, a combined expert team. So radiological experts is supporting the crime scene investigation, but any other countries, an expert who is expert on radioactive materials should support this activity. What does it mean? If you have an expert with measurement device, the guy, or doesn't matter, so the expert will measure the radiation, the level of radiation dose rate, how dangerous is it, and will give advice to the scientists and law enforcement how to protect themselves, for example, using special protective equipment, a gas mask, or I don't know, special clothes, or shielding, lead shielding, or how much time they can spend in the crime scene. This is crime scene. Another question is scientists in the laboratory. This is another which is important point, that therefore the in-field measurement is very important, because we have to if we have to plan the transport, because the transport, the material is unknown. You told very well. This is an unknown source. We don't have any information on that. Information coming from the field measurements. This is the dose rate, the radioactivity level, and isotope maybe. What kind of isotope we have, cesium, cobalt, or nuclear material. And, but this information should be, based on information, we have to plan the transport of these materials, which is challenging because we don't have license for the material, but it's possible. Follow the radiation protection rules and physical protection. And we have to inform the laboratory, because the laboratory should know what they will receive. If they don't know, of course, there is also protocols how to measure the samples before it's arriving or before they open it. Or actually in our laboratories, we have a so-called glove box, which is a plastic box with two gloves inside. And we always open any evidence inside these blocks. This is a protection against inhalation and digestion, not for radiation, but the radiation we can measure. So it's very important because it's not the same if we send the laboratory some natural uranium or some fewer pellets, or half kilo plutonium, which is an extremely dangerous material. Not radioactive, but very toxic. So we have special protocols for that. Communication again.
Since you have your protocols to protect yourselves, doesn't that mean that also the criminals have the same materials available to cover themselves from you finding them out? How are we so sure that we are not only see specific cases?
The criminals? I mean, information about the material, or yeah.
No, I mean how you said, for example, in the borders, you said that you measure the radiation from a car or something. Yes, yeah. How are we positive that that we can detect most cases and they're not using the same equipment you use to protect yourselves to hide themselves from you finding them out?
Thank you. Yes, it's happening also. Of course, there are some experts also in the criminals. Not all, most of the cases not, but they have experts also. Not the detectors are. They don't have in most of the cases detectors, but there are some possibilities really to hide the material, and it happens sometimes. But the border police in most of the countries is trained somehow to find, if possible. One example: if there is a big truck full with fertilizer, so potassium containing something, this is naturally radioactive. So when the truck is crossing the border, the dose rate will be higher. And if you hide another source, if you hide the source inside the fertilizer, maybe the radiation check won't see. But if they're checking the spectrum, if it's in a shielding, in a lead container, it will be on the spectrum some decreasing in the spectrum, because there is a shielding, lead container is shielded also the natural material. Another possibility, if there is not in a shielding, then you will even see another peak, which will be like cobalt 60 or something like that. So there are some tricks how to avoid the detectors or detection, and they are using sometimes, but we try to be, I mean, not we, the border police and scientists try to be more cleverer and have better technology to detect them. There are many projects focusing in this field. Yeah. Okay, thank you.
Well, let's thank Professor Széles again.
Thank you. Thank you very much.